In this video, I'm going to go over how to solve exponential equations in two different ways, how to solve them using writing the bases as the same base, and then also using logarithms, and then I'll solve some logarithmic equations. So really kind of three different ways that I'm solving some equations in this video. So in the first two, if you look at this number 1 and number 2, I'm going to rewrite these bases using the other one. So I see 2 to the x plus 5 power. I'm going to copy that down and rewrite 8 as 2 to the third power. Now it does say -3 in the original power, so I do have to bring that down. And then to get rid of these parentheses, when you have a power raised to a power, you're going to multiply. So 3 times -3 is -9. Now, once I get here, you'll notice I have the same base. So to continue, I'm going to set each of these exponents equal to each other. So -9 equals x plus 5. Move the 5 over with subtraction. -9 minus 5 is -14. So that's how we're going to do these first couple. Okay, number 2. Now, number 2, I cannot rewrite 32 with a base of 16, right? So I'm going to think of a different number, a smaller number. You could rewrite 16 as 4 squared, but you cannot write 32 with a base of 4, right? 4 to the third power is 64, so that's too high. So actually, I'm going to use 2 for both of these bases. 2 to the fourth power is 16, and 2 to the fifth power is 32. Copy down the original powers. Like we did in the first question, we're going to multiply when I have a power to a power. So 5 times x is 5x. 5 times -3 is -15. 4 times x is 4x. 4 times -5 is -20. And just like before, now that I have the same base, I'm going to remove the bases and just set my exponents equal to each other. I'm going to move the 4x over with subtraction. That leaves me with just x on the left side. Bring down everything else. Move the -15 over with addition. And I get x equals -5. All right, so that's how you do kind of the first iteration of solving these exponential equations, is you're hoping that you can rewrite the bases to be the same. Now, in 3 and 4, you're going to see that that's not going to be possible. So the first thing I notice in number 3 is I have a number that's in front of my base of 2, so I'm going to divide that 83 to the other side. All right, and I'm going to write 2 to the 4x power equals, and I'm not sure what 996 divided by 83 is, but we can go ahead and do that real quick in a calculator. So 996 over 83. So that's going to be 996 over 83, which is 12. All right, and then you'll notice I cannot rewrite 12 with a base of 2. 2 to the third power is 8. 2 to the fourth power is 16. So there's no way to do number 3 like I did numbers 1 and 2. So because that's not going to be possible, this is where I taught you guys to take the logarithm of both sides. So essentially write log in front of both of these sides of the equation. By doing that, that allows me to use a property called the power property to take this power and move it to the front to become 4x times the log of 2 equals the log of 12. And then to get x by itself, I'm going to divide by the 4, and I'm dividing by the log of 2. All right, log of 2 is just a number. I just don't know what it is. All right, so technically my answer is the log of 12 over 4 times the log of 2. Please don't try to reduce anything here. I know you can divide 12 and 2. That reduces, but please don't do that, right? Those are arguments and logs, so that would be not okay. So this is the answer. If you leave it like this, totally fine. You can just stop here. Or if you'd like to get a decimal, that's fine, right? We can go back to our calculator and type in the log of 12 over 4 times the log of 2. Confirm I have that right. Yes. So to the nearest, let's say to the nearest, in the delta math, it was to the nearest hundredths. So if I go to the third number after the decimal, that's 6 rounds the 9 to become 0. So that's going to be 0.90. Again, you don't have to do that for the test. I'm okay if you just left it as x equals this fraction. Okay, let's do number 4. Similar idea. To start, I notice there's a 6 in front of my base of e. So I'm going to divide both sides by 6. And I'm just going to leave that fraction over there for now as 1/6. If you want to write it as a decimal, you can, but there's no reason to. Now, because I cannot rewrite these bases like I couldn't do in number 3, I'm going to take the log of both sides. But because you have that special case where the base is e, I'm going to be using the natural log of both sides. So the natural log of 1/6. Do the power property again to move the x over 3 to the front. So x over 3 times the natural log of e equals the natural log of 1/6. And when I was teaching this to you guys during the lesson, I told you guys that the natural log of e is 1. So you can just go ahead and kind of just ignore the natural log of e now, because when you multiply by 1, nothing changes. If you forget to do that and divide by natural log of e, it's not going to change anything in your answer. So since I know the natural log of e is 1, I'm going to do x over 3 equals the natural log of 1/6. And to move that minus 3 to the other side, I'm going to multiply both sides by 3. Now remember, this 3 is going to go in front of that natural log. It should not, again, kind of like the last one, it should not impact anything with the argument. So make sure you're not doing any multiplying or dividing within the logarithm arguments. All right, so this is the answer. If you'd like to go to your calculators to get an approximation, that's fine. So I have 3 times the natural log, that's not it. Natural log, that's still not it. Natural log of 1/6. All right, which is going to be negative 5.375. The 5 in the hundredths place, in the thousandths place, is going to round that 7 to become an 8. Negative 5.38, approximately. All right, come on, pen, you can do it. There we go. All right, so that's it for trying to rewrite, or let me rephrase. The first 2, we rewrote the bases with the same base. The next 2, we were unable to do that, so I took the logarithm of both sides. In number 3, I used a common logarithm. In number 4, I used the natural logarithm. So now my last 2 are going to be solving logarithmic equations. All right, now I notice this says plus in between those 2 logs, so I will be combining those 2 logs to be 1 log using multiplication. But I do have this power that I want to move to be on the back of that argument to become an exponent. So it'll look like this: log base 2 of 5 squared. So that's going to be 25. So log base 2 of 4x plus the log. Man, I'm going to have to disconnect and reconnect my pen. It's been kind of acting super weird this morning. There we go. Plus log base 2 of 25. So now I'm going to rewrite this as 1 log with a base of 2 and multiply 4x times 25. That's going to be equal to 3. 4 times 25 is 100, and then bring down the x, and now I'm ready to swoop. So 2 to the third power equals 100x. 2 to the third power equals 100x. 2 to the third power is 8. Divide both sides by 100. You get 8 100ths. You can reduce this if you'd like. You don't have to, but if you want to reduce 8 over 100, you can. Dividing both of those by, by 4. Come on, pen, you can do this. Dividing both of those, there we go, by 4 would give me x equals 2 25ths. Again, if you want to write a decimal, to write that as 0.08, 0.08, yep, that would be fine, but fractions are just fine as well. All right, so that's it for number 5. Let's do number 6. Same process, almost identical, except we have subtraction. So I'll be connecting these arguments using division. I'm going to move that 2 to be a power on that argument. So it's going to be minus log base 4 of 4 squared. So copy down log base 4 of 2x minus log base 4 of 4 squared, which is 16. Same process to combine them to be one log, except I'm going to have a fraction this time. So I have 2x in the numerator and 16 in the denominator. Oh, don't forget your base down. That's 4. And now I'm going to reduce that, right? If I reduce 2 16ths, that's 1 over 8, or x over 8 in this case. Now I'm ready to swoop. 4 to the first power equals x over 8. 4 to the first power equals x over 8. If I wanted to get rid of that 8, I would multiply both sides by 8. And that's going to give me x equals 32. All right, so that is it for solving these logarithmic equations. All right, good luck on the test.